Welcome. In the next few lectures and this one, we are going to be using high level interactive programming language or a software called GNU Octave. GNU Octave is equivalent to MATLAB, except that it is a freeware, it is a open source free software, and it is available for both Windows operating systems and Linux operating systems. So, depending on whichever computer you use, it is available for you to download for free and load it on your computer and you can use it. So, we are going to use this program to do all the numerical computations related to phase field models in this course. So, it is a good idea for you to download this software and load it in your computer, in your laptop or your desktop, whichever computer you have access to, so that as the course proceeds you can do all the classwork by yourself on your computer and you see that you are getting the results that I am showing. And later if there are some tutorials or problems that you have to solve on your own for the course, then you will also be able to do them. There are many good textbooks that are available. Some of them are meant for both Octave and MATLAB and some of them are meant for MATLAB, but most of the MATLAB commands work on GNU Octave. For example, there is a good book by Professor Rudra Pratap called Introduction to MATLAB. So, you can use any of those books to practice for yourself. In these lectures, I am going to give a very tutorial introduction to Octave, so that you will be able to use it for our purposes. And if you have done any programming earlier, then it is very easy to follow how these programs are written. And even if you haven't, then with little bit of effort you will be able to pick. One of the reasons why I am using Octave, even though any professional quality code that you would write has to be written in a programming language like Fortran or C, the reason why we are using Octave is twofold. One, you do not have to worry too much about the programming or syntax related issues. That is a huge advantage, especially when you are writing for the first time. The second reason is that Octave is also a program which can plot and show things. So, visualization also becomes very easy when you use a programming language like Octave. So, the scripts that you write can not only do computation, but they can also show you pictorially what is happening. So, this is the reason why I have decided to use Octave, but it is not necessary that you should use only Octave. If you are comfortable with Python or Scilab or any other program for that matter, you are welcome to use. But for this course I am going to use Octave to show you the examples. So, if you are comfortable with some other programming language, you can take these same things and you can do it for yourself in those programming languages. If not, it is a good idea for you to at least learn Octave along with this course. So, there is also a tutorial that I have written for Octave, which is available as part of an NPTEL course. It is available in phase 2 in the metallurgy courses. It is called the Computational Approach to Material Science and Engineering. This is a course that me and one of my colleagues, Professor Preeta Pant, did together. So, the notes for this course are available. This is an online course, there is no video lectures for this NPTEL course. Those are downloadable, they are available at the NPTEL site. They are also available at several places online apart from the NPTEL site. So, you can just look for this course and then download. In the course in part 2, I think the third tutorial or third lecture is on GNU Octave. The third module basically is on GNU Octave. We will not do everything that is there in the tutorial, even though in the initial stages we will do what is there in the tutorial. Later we are going to do problems that are related to phase field modeling. So, some of the material that is there that can be done using GNU Octave is if you are interested in learning more about Octave and using it for your teaching, research or learning purposes. So, for now let us start with Octave. So, I have a laptop which is running Ubuntu, I think version 14.04. Ubuntu is a version of Linux, and it's a freeware, and it is available for free to download, and the versions like 14.04 and 12.04 are the long term support versions, they are called LTS. So 14.04 means in the year 2014 this got released, and that is the version that I have. That is the operating platform, Ubuntu. In that I have loaded GNU Octave. There are two ways in which you can access Octave. So I am going to show you now on the screen. As you can see on the side, so there is a symbol which if I take my mouse, then it shows GNU Octave. So if you double click on it, you will get GNU Octave invoked for you. This is the same way you can also do in for example Windows machines. So you will see when you load this GNU Octave, you will see an icon which says GNU Octave, and you double click on it, you will get the GNU Octave window. There is also another way of doing it, and that is by opening a terminal. Okay, so I have the terminal now. In the terminal I can type Octave, and if I enter, I get the same program invoked. Okay, so if you see when you invoke GNU Octave, and you will see that. So first it says, so there is some warning here. I do not understand why. Okay, generally it is not seen, but occasionally if you see some such warning, you can figure out what it is about. I certainly do not know what it is about. So generally when you invoke Octave, first it says GNU Octave and it tells the version. So I recommend that you use version 3.8.1 or higher, because everything that I am going to do then will work. Sometimes there are versions like 3.0 and they might not behave the way my version is behaving. So it is better for you to use a version 3.8 or above. And then there is a copyright information and says this is free software. So see the source code for copying conditions. Of course there is absolutely no warranty. Okay, so that is true for what I am going to do also. You are welcome to use this code, whatever I write is available for everybody. You are welcome to modify, you are welcome to share, you are welcome to use it to build other things, but finally you are responsible for what you do with the software. So this I am using here for pedagogical purposes. So I will show things, I expect you to do and learn and try to explore, but none of the programs that I give come with any warranty. Okay, so that is very important. So now that that is clear, so it says Octave was configured for x86, 64 PC, Linux, GNU. So I am using GNU Linux. Specifically, this flavor is called Ubuntu, and this is a 64-bit installation that I have. Okay. Now they also give additional information about Octave is available at http://www.octave.org. I strongly recommend that you go to this site and look around, look at the downloads, look at the manuals, look at other information that is available. There are plenty of information that is available online with respect to GNU Octave. There are lots of tutorials, there are lots of probably videos on YouTube, even though I have not explored them, but probably it is available, and you can try to learn. So if you want to learn on your own, and if you have access to the internet where you can go look up information and download, then it is very easy to learn. And like I said, there are a couple of good textbooks. Professor Rudraptap's is one. I will also give you some more names of textbooks in the next lecture, so that you can see what those textbooks are. Some of them are low priced Indian versions that are available within India, so you can use them. So this is first how to get to Octave. The moment you get to Octave, suppose you do not know anything, you can ask for help. Okay. The way to ask for help is of course to type help and enter. So let us see what happens if I do that. So if I say help and enter, so it says, so you have to say help name. Okay. So if you give help and some name, then it will tell you the information about that command. Okay. So this is what it says. So you can see, so I said help, and then it gave the information that for help with individual commands and functions, type help name, replace name with the name of the command or function you would like to learn more about. For a more detailed introduction to GNU Octave, please consult the manual. To read the manual from the prompt, type doc. Okay. So and that is it. So and then it tells you how to go. So I press the space key, then it comes out, and it also gives commands that you can use to come out, for example. So it says if I type doc, then it will give the manual. So I don't know if I have the manual loaded. Let us try. So if I type doc, well, yes, the manual is loaded. Okay. So it has all the info. So it has the preface, introduction. So you can go up and down by using the up and down key, arrow keys, so that you can use, and you can also use the space key. If you press space key, it will go down by one page. Okay, 4%, 6%. So it's going on, and you can see all the type of information you have, right. So you can also use page up, page down to go back and forth. So I am using now page down. I can use page up. So it says all the kind of things that Octave can do, right. And if you keep going down, then you will get information on each one of these things, and you can try to find out more information. So this is the full document. As you can see, it can do lots of things: arithmetic, linear algebra, vectorization, nonlinear equation, and optimization, and plenty of other stuff. Okay. So numerical integration, differential equation. So you can see that it's basically, so if you want to quit from this screen, you just type Q, and that quits. Q is for quit. Okay. So Q is for quit. So if you type that, it will come out. So the Octave program, even though we are going to use all the features that are available, is pretty powerful. You can do plenty of stuff with it. But for our purposes, we are just going to use it to solve some partial differential equations, like the ones that I have been showing you, the diffusion equation, the Cornelian equation, and things like that. And we are going to do it in 1 dimensions and 2 dimensions. 3D you can do, but I don't think using Octave to solve 3D problems is a good idea. MATLAB or Octave are not meant for scaling up like that unless you have lots of resources. So it's better to write programs which are very intensive in a programming language like Fortran or C. But for our purposes, up to 2D we will use in this course to solve, and we will use Octave to do that. Okay. So this is the first step. You have to load Octave. Of course, I haven't told you how to do that. I am assuming that you will be able to go online, look up information on loading software depending on which operating system you are using, Ubuntu or Linux or Windows, and then corresponding version you have to download. Sometimes you may have to compile, sometimes it might just be an executable that you click and then it gets installed. In either case, there will be in the case of Windows, you will see an icon which you can double click and get to Octave. In the case of Ubuntu also, you will get an icon, and just that in my case, as you can see on my screen, all my icons are lined up on the left hand side. Okay. So you can see some browser and some file manager and Octave and lots of other stuff. You can see Skype, and then you can see system load this thing, and terminal, and so all the icons are here, in which there is one icon which is meant for GNU Octave. So you can double click on that and you will get the Octave window, and in that terminal then you can do stuff. One of the things that you can do is that you can use Octave like a calculator. If you have a computer and if it is switched on, you do not need a calculator to do calculations. Okay. Well, what type of calculations? You can give anything you want, and if you have done programming, you know how to give the symbols for multiplication, division, etc., and those symbols work. For example, I can multiply 281 by 16, right. So how do I do that? I will show you. So you take 281 and then you multiply, that is a star symbol, 16, and enter, it will give you the answer. Okay. You can do a little bit more than this. For example, I can say A is equal to 281 into 16, sorry. Okay. So, the value of 4496 is now stored in A. If you do not give any variable, it is just stored in answer, and that answer will be rewritten when you ask the next question. Now, I might ask, okay, B is some 581 divided by 15, okay, right. I can now ask what is A plus B, it will give you the answer, and you can ask what is A minus B, it will give you the answer. So, simple algebra arithmetic you can do, of course, this is very nice. However, suppose I want to do another small calculation that is a little bit involved. The calculation is something like that. I know that the vacancy concentration, so I am going to write down the expression for vacancy concentration. The vacancy concentration in material is given by exponential minus delta H for vacancy formation divided by RT, where delta H is given in kilojoules per mole, and say, let us say that this is 68 I think kilojoules per mole in the case of for aluminum. Okay. R is the universal gas constant, so it is 8.314 joule per mole per Kelvin, okay, and T, so this is joule per mole per Kelvin. T is the temperature in the absolute scale, that is, let us say that I want to know what is the vacancy concentration in aluminum, given that it is 68 kilojoule per mole is the delta H vacancy for aluminum, and 300 Kelvin, which is near about room temperature. Okay. So, I want to know what this value is. So, what does it involve? It involves calculating exponential minus 68,000 divided by 8.314 into 300. Now, you know how to do this, because that is what we did just now, but how do I get exponential, right? You might guess that exponential, the command would be exp. So, you can directly write, for example, I am going to show you how to ask for help. So, you can say help exp, okay. Nothing is happening on my screen, well, okay. So, it took some time. So, it is giving you the information. So, you can see that when I ask for help exponential, so it said mapping function, okay. So, it says exponential x, compute e power x for each element of x, okay. It is saying each element of x because the x that I give could be a vector, okay. We will come to that, we will see why it is important and how it is important, but for now this x could be just a number. You can give a number, you can give, and see it is also telling you, see also log, okay. That is because the natural logarithm is called log in Octave, it is not called the ln or ln or something. So, log, if you generally say, it will actually calculate natural logarithm, okay. So, and then it gives you more information about additional help where you can get, okay. So, it is possible. What happens if I say help exponential, right? Sometimes you might not know that it is exp. So, if I say help exponential, exponential not found, okay. So, you need to know some information, for example, help logarithm, let us see if there is any information, help logarithm not found, okay. But help log, well, yes, I find help log, but when I look at log, then it gives all the information. It gives the information on exponential and log to the base 2, log to the base 10 and lots of stuff. What is this log space? I do not know what it is. So, we can find out what it is by saying help log space, right. So, it says is a function and return a row vector with n elements logarithmically spaced from 10 power a to 10 power b, okay. So, I don't know what it is, but the idea is that you can look up help, you can find out not only information on that command, but related commands. You are expected to have some idea about how these commands are called, and they are generally called by the same names in almost all programming languages. If you have done C programming, for example, you will know that exp, log and all that are available. Those are function calls, math function calls. Okay, so this is how you invoke Octave and you use it like a calculator. So let us calculate the vacancy concentration at 300 Kelvin in aluminum. What does it require? It requires me to calculate exponential, okay, minus 68,000, because remember it is 68 kilojoule per mole per Kelvin divided by RT, but this parenthesis is important because RT has to be calculated and that is what should divide 68,000. R is 8.314, so let me calculate, times T is 300. Okay. So you get 1.4445 into 10 power minus 12. This is the vacancy concentration at 300 Kelvin in aluminum. You can calculate this vacancy concentration at 500 Kelvin in aluminum. Okay. Let us say 5. So how did I get the previous command? I just used the up key. Okay. So you can use the up key, you can get the previous command, which you can then edit and you will get the answer. Okay. So when you went to 500 Kelvin, the vacancy concentration skipped from minus 12 to minus 8. So 4 orders of magnitude it has increased. Okay. So let us calculate this quantity at 600 Kelvin. Okay. So it has become 10 power minus 6. Now you might want to calculate, suppose I told you that from 300 to 600 Kelvin, I want to calculate the vacancy concentration for every 10 Kelvin and I want to plot it as a function of temperature. Okay. How to do that? That is what we will do in the next part of this lecture. Thank you.